Welcome.
Yeah, that's a good talk.
All right, so what I want to do is show you how to determine all the positive and the negative real zeros. So when looking at Descartes' Rule of Signs, what we're going to do is we're going to look at the sign interchanges between each one of these monomials, because remember, a polynomial is a sum of different monomials. So actually, I'm going to get a little space here. If we have f of x equals, you can see in this is a positive 3x. So what I'm going to do is I'm actually going to put that at a positive. So what I'll do, though, is to determine these signs, I'm going to bring them down so you can kind of see this a little bit more directly. I have a positive 3x cubed, a negative 4x squared, a positive 8x, and then a positive 8. So you can see between the terms of my monomials, I'm alternating between a positive and a negative, and then I go from a negative to a positive. So when determining the number of positive real zeros, because we've talked about imaginary zeros with I, and then real zeros, when looking at Descartes' rule of signs, the number of positive is going to be the number of interchanges we have. So we've had two alternating signs from positive, negative, negative, positive. Therefore, there's two real zeros. But that's not it. There's a possibility of having two real zeros or no real zeros. Now, the reason why I came up with no real zeros is because Descartes' rule of signs says that the number of positive real zeros is the number of times you alternate from positive to negative minus an even number. So if it alternated between the signs twice, well, the next even number that I can subtract would be 2. So there's 2 real zeros, or maybe I should probably write 0 real zeros, because 2 minus an even number of 2 would give you 0. So now let's go and look at the negative. So to look at the negative real zeros, again, you just do f of x. But now, instead of writing the f of x for the positive, we're now going to evaluate for negative f of x. So now what I do is I have 3 times negative x cubed minus 4 times negative x squared plus 8 times negative x plus 8. So now we go ahead and simplify this. Well, any negative number, it doesn't matter, it's an x. Any negative number raised to the third power is still going to be its sign. So a negative x cubed times 3 will now be turned to a negative x cubed. Anything negative squared is going to be positive. Positive x squared times negative would be a negative 4x squared. Negative x times 8 will be a negative 8x. And then plus 8. So again, let's bring down the signs. Negative, 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 positive. So now you can see there's one interchange. So the number of negative possible real zeros, or the number of negative zeros, is now going to be 1 negative real 0. Now, the problem is we can't subtract. You say, well, this one you subtracted 2, right? You subtracted an even number. Well, if you subtract 1, that means you'd have negative amount of zeros, which is impossible. So therefore, since you cannot subtract an even number, there's only 1 and a negative real 0. So for this polynomial, you have a possibility of 2 real zeros, or 0, or you have 1 and 1 negative real 0. So when you're looking at the solutions, you know that you have to have at least a 0. One of them is at least going to be negative. And your other 2 zeros are either going to be both real, or since there won't be, it's either they're both going to be real, or if you have 0 real, then the other 2 have to be imaginary, right? So that's pretty much what Descartes' rule of signs will tell us, because when I do the other problems.